Okay, we'll continue this. See, this is the formula, the quadratic formula, that is minus b plus minus under root b square minus 4ac upon 2a. We'll just put the value, that is b is equals to 2 under minus 2 under root 2 plus minus and under root b square minus 4ac. So the b square minus 4ac was 0. Okay, so this is 0, and after putting this 0, this terms will be vanished because it is 0 now. So this is a minus plus 2 under root 2. Okay, and this whole term has vanished. So this is 2 under root 2. After solving this quantity, we'll get 1 upon root 2. Okay, so because it is a quadratic equation, so we'll always get two values of x. Okay, so the value of x is 1 upon under root 2 here, but because it is a quadratic equation, the roots are 2 times of 1 under root 2. Okay, so this is the answer. Okay, now there is a question of exercise 4.3. See, I'm reading this statement. The sum of the reciprocal of Rahman's age. Listen carefully. Sum of reciprocals of Rahman's age 3 years ago and 5 years from now is 1 upon 3. Sum of reciprocals. Reciprocals, you must be familiar with this term. Suppose x is a number. So the reciprocal of x is 1 upon x. Okay, so the reciprocal means just reverse this number. Okay, so now the sum of reciprocal of Rahman's age 3 years ago. 3 years ago means suppose Rahman's age is x years. Suppose Rahman's age is x years. Okay, so 3 years ago means x minus 3, right? And 5 years from now, Rahman's age is x year. Okay, so 3 years ago means x minus 3 years. Okay, and 5 years from now, 5 years from now means x plus 5 years, right? So according to the question, the sum of reciprocal of Rahman's age 3 years ago, that means x minus 3. Okay, and 5 years from now, that means x plus 5, is 1 upon 3. Sum of reciprocal. Okay, so according to this particular problem, after 5 years, the age after 5 years will be x plus 5 years. Okay, x plus 5 years, and 3 years ago means before 3 years it is x plus 3. So as per our question, the sum of reciprocal, so 3 years before means x minus 3. So the reciprocal of x minus 3 is 1 upon x minus 3, and the reciprocal of x plus 5 is 1 upon x plus 5. Okay, and this sum is equal to 1 upon 3. So after cross multiplication or basic simplification, you will get this line. This is x 6x plus 6 x minus 3 and x plus 5. Okay, so after basic simplification, okay, you can easily do that. So after basic simplification, x square minus 4x minus 21 is equals to 0. We'll get this particular quadratic equation. Okay, so we'll use the splitting the middle term method to break the middle term, so we can easily solve this quadratic formula. So see, this is 21, and this is the coefficient is 1. So 1 into 21 means 21. Okay, and 7 threes are also 21, and 7 minus 3 is also 4. So this is 4. We can write 7 minus 3 at the place of 4, and after multiplying this minus sign inside the bracket, you will get minus 7x and 3x plus minus plus 3x and minus 21. Okay, you will make a pair of these two expression, and these two expression you will take common. You will take common, and you will get two factors, that is x plus 3 and x minus 4 is equals to 0. So the value of x is minus 3 and plus 7. the age of any person cannot be a negative number, right? The age of any person cannot be a negative number. It's always positive. Age cannot be decreased, no? It always increase. So it is minus. This can be neglected. Age can't be negative. Okay, so this value can be neglected. Okay, so our answer, the value of x is 7. So the Rahman's age is 7 years. Okay, now nature of roots. See, we know that after solving a particular quadratic equation, we'll get to okay, after solving a particular quadratic equation, you'll get two answers. That means roots. Okay, so the roots of that particular equation is real numbers. Okay, or it can be 0, or it can be equal. Okay, so this is suppose there is a equation, standard equation, ax square plus bx plus c is equals to 0. The quantity b square minus 4ac is known as discriminant of the above quadratic equation. I have already told you. Okay, and it is denoted by d, that is b square minus 4ac. Okay, note 1 that if d is greater than 0, that means this value of d is greater than 0. In previous question, the value of d was 0, equal to 0. Okay, so the roots were same. Okay, see in this question, see in this particular question, the roots were same. Because the value of d was 0. See, the value of d, that is this quantity b square minus 4ac, it was 0. See, now if the value of d is greater than 0, then there will be two distinct real roots. Distinct means it will be different. Okay, it will not same, right? So two distinct real roots. When d is greater than 0, it will be distinct roots. When equal to 0, we have already solved this problem when d is equals to 0. So we'll get the two equal roots. Okay, clear? Now, what if d is less than 0? This is a little bit complicated to you, and it will not have no real roots. It will not have the real roots. Okay, so now you will see the related questions related to this particular problem in your 11th class. Okay, it is imaginary roots. Actually, you'll further read it in your next classes. Okay, now find the nature of roots. This is a question of your exercise 4.4. So I'm reading the statement. Listen carefully. Find the nature of roots of the following quadratic equation. If the real roots exist, find them. Means we have to find the nature. Nature means if it is real or equal, or okay, if it is not real. Okay, so we have to find the nature of that particular root. So we have an equation that is 2x square minus 3x plus 5. This is an equation, quadratic equation. Now you'll simply compare this equation ax square plus with our standard equation, that is ax square plus bx plus c is equals to 0. You will have a is equals to 2, b is equals to minus 3, and c is equals to 5. After calculating the value of d, that is b square minus 4ac, you will get the answer that is the value of d. It is minus 31, and minus 31 is less than 0. Minus 31 is less than 0. So d is less than 0. So the roots are not real. Roots are not real. Because it is not real, we will not find that roots. Okay, if it would be real number, then we'll find easily by any method, by quadratic formula method, or splitting the middle, or squaring, complete square method. Okay, but because it is not real, we will not find it. Okay, now it is a simple problem. See, find the values of k for each of the following quadratic equation, so that they have two equal roots. Two equal roots means what? Two equal roots. When we'll get two equal roots? will get equal roots of any quadratic equation only when d is equals to 0. Okay, am I right? Because when discriminant, that is the value of d is equals to 0, then what we'll get? We'll get two equal roots. Okay, I think I'm clear now. So this is our given equation. So the given equation is kx x minus 2 plus 6 is equals to 0. On simplification, you will get kx square minus 2kx plus 6, that like standard form. Okay, so this is on comparing with the equation ax square plus bx plus c. You will get the value of a, b and c, and because roots are equal, so this is an important step. Okay, so listen carefully. So this is when roots are equal, so what will happen when roots are equal? So the value of d will be 0. Okay, so the value of d will be 0, and the value of d is b square minus 4ac is equals to 0. Okay, just put the value of b, c and a. Okay, so this is the value of b. It will be 4k square, and this is minus, after just submitting the value here. So this is 24k. After taking common, you will get the value. After taking common, you will get two values actually. Why two values? Because it is k square, right? It is k square when you take common. So you will get two values of k. That is k is equals to 0 and one value is 6. Okay. So this is the solution.